We've talked about how spontaneous reactions are often exothermic, but not always. Or, in other words, delta H being less than 0 favors spontaneity. We also discussed how spontaneous reactions are often associated with an increase in entropy, but not always. In other words, if you have delta S greater than 0, that favors spontaneity. The Gibbs free energy is a thermodynamic quantity we can use to always be able to determine the last word on spontaneity. When the value for Gibbs free energy is less than 0 or is negative, the forward reaction is spontaneous. If Gibbs is greater than 0, the reaction is non-spontaneous. And if Gibbs is equal to 0, that tells us that the reaction mixture is at equilibrium. Several times we've mentioned that delta H being negative, i.e. exothermic, will contribute to a negative delta G. Okay, so if delta H is negative, it's going to contribute to delta G being negative. If delta S is positive, that's going to contribute to a negative delta G. That's because the negative T delta S is going to be a negative value. Here's the complication. A reaction can still be spontaneous, i.e. have a negative delta G, when delta H is positive, or if delta S is negative. So if delta H is positive, as long as this value T delta S is large enough to overcome that and make delta G negative, we can have a spontaneous reaction. There is a temperature dependence on the overall spontaneity. These points are summarized in this figure from your textbook. However, I think it's much easier to use the following. This is how this mnemonic works. We're looking at the sign on delta H and the sign on delta S. When delta H is less than 0 and delta S is greater than 0, at all temperatures, this reaction will be favorable. Remember, what we said is when delta H is less than 0, it tends towards favorability. When delta S is greater than 0, that tends towards favorability. So when you have this situation that delta H is less than 0 and delta S is greater than 0, that means at all temperatures, okay, here, all temperatures, this reaction will be spontaneous. If you have the situation where delta H is less than 0, delta S is less than 0, that means at no temperature will that reaction be spontaneous. Remember, delta H greater than 0 means endothermic. It's going to tend towards non-spontaneity. Delta H being less than 0 also tends towards non-spontaneity. So at no temperature, no T, is this situation going to lead to a spontaneous reaction. Okay, the next situation, delta H is greater than 0, which means it's going to tend to be non-spontaneous. Delta S greater than 0, which means it's going to tend to be spontaneous. Now, if we look at the value for delta G, we see at large T, or at high T, the factor T delta S is going to be large. So even if delta H is positive, if you have a very large negative number, then delta G is going to be negative. That's why in this situation, the reaction is spontaneous at high T. Now the last situation, delta H negative, exothermic, which means it's going to be favorable as far as delta H. If delta S is negative, this whole factor, negative T delta S, is going to be a positive value, and that needs to be small in order to not overwhelm delta H and for delta G to remain negative. So this reaction is spontaneous only at low temperatures. So here's our mnemonic. All T, no T, high T, low T.